The talk that I prepared is more like a case study. So any one of you are in the business of building infrastructure in a way? Show of hands. Okay, cool. Have anyone have fun in a data center? You're lying. No one have fun in a data center. For me, it's like going to Disney. I know, but yeah, it's kind of interesting. So what I did today was I prepared. It's more like a case study about what we had to do in Latin America, and the title says it. Everything is we build the whole cloud service on the edge using open source tool. My name is Ramirez. I'm a CEO of Cuemby. Cuemby is a company that specializes on helping companies with cloud, DevOps, and AI. And the way that we focus on three things. First, it has to be to accelerate innovation. Two, it has to focus on reducing costs. And three, we have to, in a way, improve productivity. So those three things is what we focus on, and that's how we help companies, adopting all these cloud-native open source tools. We are heavily involved in the community. In fact, we support almost every single community in Latin America because we truly believe in open source, and we know that that's the future of the world. So we wanted to put it out there. Myself, I'm a CNC ambassador. Also, I'm OSPO ambassador. Therefore, I love open source. And I'm also called Cube astronaut. There's a couple more here. I know they have the jackets on. So that's kind of so you can know about myself. So first thing first, and we need to address the elephant in the room. Why, Angel, do you want to build a cloud provider? We have already so many, but we need another one. So first is that, in this case, the focus on hyperscalers, they cannot reach all the regions. And as I started at the beginning, I'm focusing so much in emerging markets like Latin America, APAC, EMEA, Southeast Asia. So they don't have regions there. Two, low latency applications, those require to have the hardware near to them. So that's why we need another one. And the third is that emerging markets are really underserved. If you look at the OpenAI cloud provider hyperscaler website, you will see that US, Europe, and Australia, Asia, they have a lot of regions and presence. But then when you look at, say Mexico all the way down, there's none. Or if they have, it's very little. So we had to make sure that they have what they need. So that's how we end up with a mission of we need to build something. Of course, as a startup and a company that relies a lot on open source, we don't have the billions to build data centers from the ground up. So we were in the sense how can we use all these open source tools that we know, and how can we bring them to them in a way that is cost efficient, of course, and they don't have to break the bank. So that's how we end up saying, well, there's a lot of data centers. And by the way, this is a really good metric for you to know. There is about 6,200 and something data centers in the world. The top 5 hyperscalers only have 1,250 something of those, meaning that there is another 80% of data centers that are not in the cloud business. And we could use them and help to, first, they can have their spare capacity, the one that they're not using, we can put it to work. And for companies, a startup business, large business as well, that they need access to these resources, we can connect them. So it's kind of like Airbnb. So we don't build any of the hotels, but we know the rooms and we put it to work. So that's kind of how we got this crazy idea. But as you can see, the main purpose here is we have to use open source. Why? Because we truly believe that that's the future of the world, and also because we want that to be able to be flexible, expandable, and can be translated to anything else, right? And the one other key item is that a lot of the people that we talk to, they need low latency applications, so we have to be able to access those at small data centers sometimes tier 2, tier 3 data centers that may not have a lot of capacity, but they're close to their applications. So this is kind of like, I want to show you the snapshot of what we have first before I show you all the crazy stuff that we do. But just to show you, we already have 3 regions running at the moment, Colombia, Ecuador, and Chile. We also already have the plans and the roadmap to expand to 10 countries, 16 locations by the end of this year. And the idea here is, how can we have more data centers to join that network? That's what we're putting here on the table, so we can actually have them benefit out of this. Okay, so the question is, why open source? We all know, we are here because we love open source, but the key points are no vendor locking. We don't want them to feel like, oh, we're using the Cuemby cloud. No, you're using open source. We just happen to be a brand, but it's open source, right? Has to be cost efficient. We don't want to spend a lot of money on this. We want the community support. That's why we always help in the community in a way that we can, but why we also want to grow the community, because everyone benefits out of this. And of course, the security and transparency that open source brings, which, interesting enough, when you talk to enterprises, they always say like, open source doesn't seem secure. It's the other way around. If you're using open source, everyone knows what's going on, so everyone can really tell you it is secure or not. And of course, it aligns with our values. We truly focus on open source. Okay, so the fun part, the tech stack. I'm sure that you're noticing here, where is Kubernetes? I'm gonna get there. But here's the thing, interesting enough. First, we did a lot of testing, and when you're working with Kubernetes and bare metal, especially in the data center, it is not that fun. So that's why we put it aside for a second, and let's say, okay, well, Kubernetes can help in another layer, but let's focus on like, I got a rack of servers here, and how can I put it to work? So after doing many testings, and some of you here even aware of the test that we did, we end up with this. And I'm gonna show you some screenshots of what we have with this stack. First, we had to provision the bare metal service. If you've worked on that before, you know that that's a pain, provision bare metals, especially for other reasons that I'm gonna show you later. But we found that, Tinkerbell, great tool. There's another one like Mr. Provisioner, all that. But why we end up using mass, to be honest, is because of the capability they have and the how robust it was when using it. And it was pretty quick. We just set up the first server, and anyone that was in that network automatically got provisioned with what we needed. So it solved that problem. And just to show you that I'm not lying to you, probably say, hey, this Q1 is lying to me. Come on, show me the money. So here is actually, I'm trying to connect if the network let me. Of course, the network is trying to reconnect. Well, anyways, as this is trying to connect, wait me a second. It happened something to a network. What? It looks like the Austin public library is not helping me out. Okay, let me see. Well, the network failed. Anyways, so I was going to show you the mass. Am I doing something wrong here, or it's just because it's supposed to be connecting? I was literally looking at it like 2 seconds ago. Anyways, but just to show you how mass works, it just you give them the provisioning. Yeah. No. Actually, I disconnected from the VPN exactly because of that. I did a port forward just to avoid the VPN things in the public network, but I don't know. Sometimes it's just acting out like that. I don't know. But anyways, so mass gives you the whole way to provision the servers, but it gives you a little more. It also helps you set up a DHCP server, DNS. You can actually filter a lot of the networking side. I don't want to bore you with a lot of the networking part, but it's very exciting and terrifying at the same time, because you have to manage tags on tags networks, how you're going to merge them together, how you're going to do all that stuff. But mass allows us to do that very well. It has an API, so we can do it programmatically. it has really nice terraforms and Ansible playbooks, so we can manage all that as well. So I'm gonna jump to the next one before I talk about cloud stack, which it was mentioned. I was not planning to hear that word before my talk, but I mean, Chris Aneshik mentioned cloud stack, which is interesting. But I mean, talking about the network, we actually combine micro VN, pfSense, WireGuard. Why? Because we need to secure the whole network, and also because at the end, when you're looking at the data center, you still have to create that secure environment before even being able to provide virtual machine services to the clients. So basically, WireGuard became the standard in terms of tunneling. It's great, it scales very well. And the reason why we went to WireGuard is because in the future, when we're connecting to the Kubernetes layer, we want to transfer that networking in an easier way. pfSense, just making sure that everything is as a firewall, open source. And micro-VM, which is the one that helps us do the overlay networking between MAS and the machines that we're going to deploy on top of it. Interesting enough, MAS is not the only piece of work that we're using from Canonical. We're also using microcloud. It became really nice for us. Microcloud is a combination between LXD, MicroCEF, and it's not VN, it's the other one. But it just combines very well, and it works excellent for edge. Remember, what we're doing here is we're deploying edge computing. So everything, look at the one region for us could be like one rack, 10, 20 servers, that's it. That could be Bogota 6A, and then the other rack could be Bogota 6B, and that's how you scale, because it's all about edge. And microcloud provides all the plumbing that I need. And LXD, interestingly enough, it gives me the first layer of virtualization that I need to provide these services. Just to show you how it looks like, and this one I took a picture so the internet doesn't crash on me. If you can see here, this is how we prepared the region 1, right? So we have a couple of all those machines that you see there are the same bare metal servers, but we just virtualize it and put it on that overlay network. That gives me the first network security. So if someone trying to get to the server, good luck with that. And then you see that we have the pfSense that is acting as a gateway. So none of those machines go outside to the internet by itself, always through a firewall. And then we have the MAS server there, which is the one that provisions all that. So we were able to set up that in literally 4 hours. That's how fast we were able to do it in terms of the networking. And then LXD helped me manage that part, right? Then Ceph, I put it there because we're using MicroCEF. So instead of having the storage just like that, we use those RAIDs, and MicroCEF basically provision and manage all that for us. Very, very simple. And of course, we got the monitoring stack, which you probably already all know, Prometheus, Grafana, and OpenSearch. But instead of having it on top of Kubernetes, this first layer is outside of Kubernetes. We do it with VMs, auto scale, and all that, because we need to monitor everything, not just the Kubernetes part. We need to monitor everything from the networking side up. So now, cloud stack. Why is cloud stack there and not Kubernetes? Well, this is the reason why we put Kubernetes in a different layer, because at the end, what we need is something solid that already is being proven. Cloud Stack has been proven, OpenStack also as well. We test with OpenStack, with OpenNebula, with Cloud Stack. We did like 20 tests, and we ended up with Cloud Stack because we found that it's the easiest, it's pluggable. We can build any plugin that we want. And by the way, it has all the orchestration built in, including Kubernetes. So on top of Cloud Stack, we can just deploy as many Kubernetes servers as we want, and that's what we use as our final layer. Basically, it's been great. I can show you a little bit how it looks like if the internet, okay, the internet's here working now. As you can see, let me just make it bigger. Is that big enough? Yeah. Perfect. So this is just an example of virtual machine being deployed. If you see, virtual machine gets only private IPs. There's no public IPs involved there, even though that you can access from the internet, but everything is through a firewall. So why this is important? Because when you're talking to a bank, they don't want to hear public. You just don't even mention. I assume that public means 0. So when I show them this and they're using our cloud, basically they see, okay, this works for me. So then you have all these options, instances. You have Kubernetes here. You can create Kubernetes cluster, all that kind of stuff. Very fun, to do. It's just everything that you need. You can create any type of networking. Interesting enough, you can even create isolated networks, shared networks, overlay networks. Pretty useful. So that's why we went with CloudStack, because it basically does everything that we need. Now, though everything that is there works, but it's not as simple as you think to configure. That is the downside of CloudStack versus OpenStack. OpenStack, you install and runs. That's it. Pretty much the configuration that you have to do is minimal. CloudStack is completely different. CloudStack is like, I'm gonna give you hell to install, but once you do, you're good to go. It's gonna scale. So that's how we basically end up to choosing CloudStack, because our engineers, they feel very comfortable in the networking side, so preparing all that, the tunnelings, the tags on tags, that's what Mass comes in. Mass help us do that, so we didn't have to, suffer the other side. But just in case you want to test it out, CloudStack is amazing, but the configuration is gonna take a while. By the way, all the configuration, we have it here. This is like just a snapshot of what we're working on. We got Ansible, we got also Terraform / OpenTofu compatible code. We are going to be open sourcing these as soon as everything is nice and tight, so you can also test it out and work on it. The whole point here that we're doing is the way that we deploy our own cloud, we open sourcing that. So if you want to try it out, do it yourself, and you don't have to pay a dime for doing it. We already solve it for you. But the interesting part is you cannot just choose one tool. That's why automation is important, to understand the right tool for the right job. We thought, let's do everything with, Terraform. No, it doesn't work like that. You need to use Ansible in some places, because configuration is better when you're using Ansible. At least that's been our experience. But you can see here, we got roles. Actually, this is interesting because I'm working on this one personally. When you have the CloudStack, how you feed the images. You have to upload images so you can offer it to the clients. That is painful. I didn't know that until I had to do it. So basically, I developed these Ansible playbooks and roles that goes to the official images, downloads the QCOW2 images, injects what you need for CloudStack, then deploy it to a mirror, and then from that mirror, I'm using Terraform to then configure the CloudStack, uploading the images and make it available. It's a lot. The good thing for you in the future, short future, is that I already basically built the whole thing, so you're not gonna have that pain, but just to explain, that's kind of the workflow that we had to do. All that is gonna be automated through GitHub Actions and all that, but that's kind of how it works. Just to show you what I mean, these are all the cloud images that we're working on, from Alma, Linux, Rocky, Debian, and all this list that you see here is what it does, the downloading, the uploading, configuring, because there's one interesting thing in CloudStack. When you deploy an image, it wants to inject a password so you can use it, right? Here's the interesting part. CloudStack has one specific cloud init that you have to use. If you don't do that one, it won't work. So we already did that, and that is exactly, I believe, from this template. No, this is the other one. It's in this task. As you can see here, all these tasks are those specific changes that need to be done. So once I'm going to be posting this so you can see and also contribute, but it's very interesting the way that it works. So that is why we chose CloudStack. Some people feel that CloudStack is dead. I don't think so. It's actually becoming more alive. Version 4.20 is actually pretty neat. It comes with a lot of features, so I will definitely encourage to test it out. So I'm going to glance through this slide because I don't want to take too much time of the other speakers. But for example, this is the way that we structure our, let's say, our data centers access. So everything is span leaf, like normal standard architecture. But always keep in mind that for us, one rack is an entire region. So every single rack is a cloud stack setup. Why we did it that way? Because we also had to make sure that we provide isolation of data. As Andrew Martin was saying in the morning, everything needs to be isolated, even within their own data center, so you can have a better service, right? Basically, we had to adapt. We found a couple interesting things, but for example, in Latin America, and I feel that we here in the US are very privileged. In Latin America, we have something called outages. And they often occur like every 2 hours you can have an outage. So although data centers are very secure and they have enough power and use for outages that can last like 8 to 16 hours, it's not reliable. So you have to adapt. So that's why for us it's edges. Because if we put everything in one data center and happens to be that one goes down, no one's going to be happy. So that's why we adopted the edge strategy, so we can spread across. Okay, also the uplinks, the internet, we don't have the same high speed. However, we did partner with a great company that actually is very well connected in the whole Latin America. So at least we have secure 100 gig uplinks. So that's pretty nice. And but then you basically have to end up with that, and you have to do a lot of backups. That's why you have to adapt to the local conditions. So if you're trying this, keep that in mind, because those are roadblocks that you're going to have when you're building a cloud provider. Basically, automation is the key. I showed you already some of the automation. I know that people sometimes make it work and then automate. In this case, we had to do it the other way around, because if you make it work, you do a lot of manual work, and then you forgot what you did, especially when you're running a lot of scripts on the data center. And this is the security approach that we took. This is where I was showing that everything has to be isolated. That's why I showed you the PF-Sense, that's why the overlay network. All that is to basically connect to this idea of like everything has to be secure from the bottom all the way to the top. Lessons learned, a lot of them. We basically cry and cry and cry, but we end up making it happen. But these are the lessons that we got from the scaling. Hardware, sometimes the hardware is not the same. We found one rack that they give us literally every single server was a different brand, a different version, a different everything. And yeah, that's the one that makes us cry the most. But that's why using this open source tool helped us out, because we did just minor tweaks to make it work. Documenting everything, believe me, if you run scripts, you forget. Always document, automate day one, and then the monitoring the whole life cycle is something that did help us a lot. That's why the Grafana and Prometheus was first. Usually you start doing everything and then a monitor. We had to start from the beginning. That's how we noticed that the hardware was not working the way that we were expecting. And plan for failure. No one wants to fail, but you have to plan for it. What went wrong? Everything. What went well? Everything. We didn't get it in the right way, the right way the first time. We basically failed a lot. But that's good, because every time that we failed doing something, we found all this stuff that the answer always was there's already someone in open source that knew that, and we basically benefit from that. That's why we want to continue back to it. So I'll basically summarize this slide in that way. Everything will fail, but everything will be fine, because we're using always open source. There's no closed source. Community matters. We love community. 100% is the way to grow. Actually, when people ask me like, what's Cuemby really? I'll say it's a company that was born out of community, because that's how I end up starting my career, because of the community. That's why I keep doing community, because at the end, that's how it has to be. And the reality is all this stuff that we need to find out. But at the end, we made it happen. Just keep in mind, out of all this, is that always try to balance cost and performance, especially when you're dealing with infrastructure. And no one wants to hear this word, but there's something called CapEx. So if you don't focus on like being cost efficient, CapEx will kill you. This is the current status. Actually, we were able to get all this right, which is good. Yes, 9.999 uptime so far, and running a lot of good virtual machines so far. So, wish me luck. Okay, the roadmap I kind of mentioned at the beginning, but what we're looking forward to do is always that. Continue open source contributions and focus on like everything that we do in the cloud that we're building, we open sourcing it, and then we continue growing in terms of regions. That's the way to go. That's the way that we set that path. We already talked about this one, so I'm going to skip this slide. But I would like to invite you, everyone, to the upcoming KCD Colombia. This is a shameless plug. It's another community that we help and contribute, and we're looking for speakers. We're looking for people that want to volunteer, or if you want just to have fun in Colombia, it's amazing. We're going to do it in Bogota. This is the third edition that we're doing in Colombia. We did already the 2023, 2024 was the Cube Day in Colombia, and now we're going to be doing the third edition. So this is the QR code. If you want to be there, participate, feel free. And I think that's all I got. This is my QR. If you want to connect with me, I'm very active on LinkedIn. And I don't know, happy to answer any questions if there's any, or we have some time or not. We're good? Oh, we got time? Oh, I went fast. Oh, okay. Any questions? Yes, sir. Yes, actually, we already have. We're testing now with 5 initial GPUs. CloudStack has a really nice plugin that recognizes the GPUs. And the reason why we're testing it because we have another data center that have about 300 GPUs that want to put in the farm. So we're doing the test. Here's the interesting part. For the GPUs, what we found very interesting is use it just to recognize the hardware and put it to work. But if you want to put it as a service, Kubernetes. The Kubernetes operator for the GPU NVIDIA is way better of what you can have outside of that. So I would say just use CloudStack to like get the hardware, recognize it, and put it to work as a virtual machine so they can take benefit out of it. But that's it. Don't spend too much time on trying to make that plugin do more than just that. Sorry, what was that? Is there a pricing model for this? A pricing model in what sense? Sorry. To be able to use services like actual service. Oh, yeah. So I'm showing you the open source part. So you basically, what I'm showing you is like, you can build your own if you want, and you don't have to pay a dime. Basically, it's hardware what you need. Now, what you're asking is how I monetize this is basically through this. This is just a dashboard that is more for the end consumer, like anything. It's very similar to like Linode or DigitalOcean. So you just can go, sign up, get virtual machines, Kubernetes clusters, that's it. So that's the monetization part, but this is just the face. Nothing in this one dashboard that you see here adds anything that is not already available in CloudStack, because CloudStack, the only thing that doesn't have is a billing system, that's it. It even has a really good usage plugin, so it basically takes all your accounts and knows how much you're using for network, standpoint, CPU, RAM, everything. So it tells you everything. This is more like a face just to like charge clients and manage the organizations, that's all. Actually, second that, a follow-up to that one is CloudStack. I like the way that it's structured, the organizations and projects, because it's very similar to how AWS does. So it transfers almost one-to-one. So they even have a plugin for AWS compatibility API. So you can basically talk to CloudStack like you were talking to AWS, and it works exactly the same way. All right. Any questions? Any other? Yeah. Great. Awesome. Thank you so much.